Alright, today we're looking at handout 3. We're continuing on with area. Name each shape below and determine what characteristics that they have in common. Who knows what that is?
What, this one?
That shape right there, this one.
A rectangle.
Good job! Write it down. Might have a quiz on it. Who knows what this one is?
Rhombus? Trapezoid?
Nope.
Equilateral.
Let's go.
What? Hey. Parallelogram.
There you go, Shay. Parallelogram. 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 What's this one? What is this one?
Triangle.
Square.
What's this one? What's this one?
A trapezoid.
Crap. I'm still working on the triangle.
That's something. You didn't know it needs writing, right?
Okay.
Yeah.
Similarities, differences. What do we see that's the same? Raise your hand. Check. You see two triangles. Triangles are made up of what? 3 sides and 3 angles. Good. And so, what's the difference between this one and this one?
That one has a right angle.
That one's a right triangle. This one is
Scaling.
scaling. Probably
I saw
acute.
Yeah.
All the angles there probably are acute. Okay. What else do we want to compare? Davis?
Square.
The rectangle and the square.
Rectangle and square. How are they the same?
Their angles are right.
Right angles. Good. How many sides?
Quadrilateral.
They're quadrilaterals. What does that mean?
4 sides.
Okay, so let's write that down. Quad means 4, so this is anything with 4 sides. So everything except the triangles here are called quadrilaterals. That's like their big umbrella of what we call them. They're all quadrilaterals except for the triangles. And then they have differing characteristics. So Davis says the rectangle and the square have 4 right angles, and they do. What's the difference between them?
What?
The sides.
The length of what?
Rectangle.
On a square, all of them are even, and then on a rectangle, it's like they have 2 different sets of even sides.
Okay, do you remember one can be the other, but the other doesn't always have to be the other one? Do you remember which one's which?
Rectangle can be 2 squares, but the square can be 1.
I think it's the opposite way.
Huh?
Square can be classified as a rectangle, but a rectangle doesn't have to be classified as a square. So squares always have equivalent sides. Rectangles don't have to have equivalent sides. Let's talk about area. So area is the surface measurement of a 2-dimensional figure. So 2-dimensional, you can draw it on paper.
Is that just like a square?
Anything you can draw, a square, a triangle, trapezoid, parallelogram,
I was thinking
odd shapes that aren't any of those.
Exotic.
Brainstorm at least 3 real-life examples of area. Just look around the room to help you. So what are some things that take up area?
the ground.
Okay, whiteboard.
The ground.
Ceiling.
The walls. Everything in here, actually.
Mm-hmm.
Everything is made.
Whiteboard. Ceiling. Walls. How about the clock? Bulletin boards.
Can we just write everything?
Tables. Literally everything.
write all that and then write over.
Area. Count the dimensions of each of the rectangles below and then count the number of squares inside. So here we've got length and width. It really doesn't matter which one you want to call length and which one you want to call width. We just need to be standard when we're talking about it together. Which one do you want to call length? This way or this way?
Top to bottom.
This way?
Top to bottom.
Top to bottom? Vertical?
Vertical.
Okay. 1, 2, 3, 4, 5, 6, 7. Width. 1, 2, 3, 4, 5. Now, count the squares. 35. Did you count?
No.
What'd you do? You multiplied.
Yeah.
But I want you to count them.
5, 10, 15, 20.
Okay, length rectangle 2. 6. Width. So how many squares?
54.
Length.
4.
Width.
4.
Total squares.
16.
I said 8.
So what pattern do we notice? We can multiply the length times the width. So. Multiply your length times your width for total squares. Are you good?
Good enough.
Describe how this pattern could be applied to the picture to the right, and then find the area. So what do you think we need to do? Multiply it, you were saying multiply the what?
The whole number.
Multiply the whole number? Okay. Well, before we defined our length and our width. So what's our length here?
8.5.
8.5. 8.5 is fine. And then what's our width?
23.
3.
What is that weird little shape?
This shape, it's called a doorknob.
Oh, it's a door.
It's a valid question. Okay. So Paige says multiply the whole number. So she says 8 times 3 is what?
24.
24. Now what do we have to account for?
3 times 1/2.
3 times 1/2. Okay. What's half of 3?
1.5.
So now we're going to add those two pieces together. What's 24 plus 1.5?
39.
Where at?
What?
25.5.
25.5 or 25.5. Now take your calculator and do 8 1/2 times 3 and see if we got it right.
Oh.
20.
8 1/2 times 3.
25.
Yeah, we got it.
25.5, yes.
Good job. And so this is in feet. You need to remember that area is in square units, literally. Just like the ones we just completed is counting squares. So you put the 2 there. Someone asked last week, well, why is there a 2 there? Well, if we're talking about feet, this is literally 1 foot by 1 foot. So it's foot times foot, which means we can simplify that by you giving it an exponent.
Oh, yeah.
Because that's what an exponent means. It means something times itself that many times. Like 2 to the 3rd power is 2 times 2 times 2. So ft, or feet, the 2nd power is feet times feet. Any questions? The dimension of the parallelogram can also be referred to as the base and the height. So yes, this is a rectangle. It is also a parallelogram because opposite sides are parallel. Sorry. Count the dimensions of each of the parallelograms below, and then count the number of squares inside each. So you see that the parallelogram number 1 is called rectangle 1. They just happen to form right angles. Opposite sides are still parallel. What does parallel even mean?
Like across from each other.
Directly across, they're equidistant, which means equal distance from each other at all points. So if I take two lines and I measure the distance between them here, and I measure the distance between them anywhere else that they exist, it's always the same number. Basically two lines that never cross each other. So if we're looking at a rectangle, this line here never crosses this line here. If they go on infinitely forever, they still never cross each other. None of them are tilted towards each other. And then this one and this one are parallel to each other. They never cross. Base. So if we're talking base, how many units is the base here?
6.
6. And we're talking height. How high is it?
4.
And so how many total squares?
24.
Okay. Base on this one. So ignore the fact that it's got a slanted line with an arrow on it. What's the base?
7. I mean, 6.
6. What's the height?
4.
What's the total squares?
24.
What's the base here?
9.
What's the height?
7.3.
What's my total squares?
Okay. 65.7.
And each one of these needs a square unit. And if they don't tell you what unit, you use letter U that stands for unit. So what do you notice about the parallelogram height on this one?
So what?
What do you notice about the height?
It's got a decimal.
Is it this?
It's slanted. So,
Are these the heights?
This one?
No, they're not. Those are not the heights of the parallelogram. The height is that dotted line that you see. This is the height. So if I've got a rectangle that's been squished and I'm calling it a parallelogram, how do I measure the height?
Go straight up the middle.
Straight up the middle?
I mean,
So,
straight
right
up
here?
No, I mean straight up.
That would work. What do I have to do?
Go from the bottom line to the top line. Not, but not.
At a what angle? All right, who said right? Page, good. So the height is where you go from the base on the bottom to the base on the top in a right angle. So it's got to form this right angle right here. So it's how tall it is there. It's almost like you took this triangle. Imagine if you drew it like this, you'd have a regular rectangle. So you don't use the slanted part. They will give it to you sometimes to try to trick you. Don't use the slanted measurement right here. Make sure you're using the measurement that is 90 degrees to the base. If you need to write that down somewhere on your piece of paper so you understand it, do that. When you're measuring the height, it must be 90 degrees to the base. Do not use the slanted measurement.
All of them was labeled centimeters.
This one was. These two are just units. So we're going to summarize. So area for a rectangle is length times width. If it's a parallelogram, it's base times height. Write those down. Okay, you're going to work with a partner or by yourself. If you prefer to work by yourself, that's fine. You may listen to music while you work if you are working alone. If you're working with a partner, well, you just make your choices. Bring me your homework when you're finished so I can check it. Don't forget to use the correct units on your homework. When you finish the homework, and I've checked it, you have prodigy 50 questions. That is for today and tomorrow to get finished. So if you leave me for RTI, you need to be sure that you're squeezing that in there somewhere. 5 minutes before class, RTI, mess, lunch, I don't care. Squeeze it in somewhere. 50 questions. Any questions? Show your work, use a calculator. I want to see the formula written. I want to see the numbers you're using for the formula. And I want to see the answer with correct units. Don't forget to study your circumference and area for circles.
This one's gonna be real easy.